for this subject. Okay. Our objective for this lecture is to understand the concept of conditional variance, because in classical linear regression model, we assume that there is homoskedasticity. However, in all of the time series data, homoskedasticity conditions cannot be achieved because the data always in heteroskedastic manners. Okay, and how to detect calm and while periods in stationary time series? Because, for example, in the crisis, we always find the while situation in our data, and in the stable states, we will find the calm period. Okay, and then we understand what is the autoregressive condition of heteroskedasticity model, how to test the arch effects, and then we estimate the arch model. And because there is a limitation about the arch, so the model is developed to be GARCH model. Okay, and we have also GARCH M. This is a mean. We use mean of the variance, and T-GARCH. T-GARCH is usually we use in the financial economics, or to detect whether there is a symmetry or asymmetry condition in our model. And also we have E-GARCH. All of the model will be estimated by using FUs. Okay, model attitude of investor, not only toward the expected returns, but also toward risk or uncertainty. Okay, if you are an investor, you always to determine whether there is a return, because in high return means that's high risk. We have also risk here. Okay, if you are having high risk, that means you have high return. Okay, require model capable with dealing of volatility. In the model of the there is a return and also risk. The standard normal model is not applicable in this one. Okay, so we use arch model, okay, to capture the return and risk together. Okay, without using the arch model, we cannot determine whether there is a return or the risk. Okay, conventional econometric analysis view, variance is 7 constant over time. This constant over time is homoskedasticity. This one, homoskedasticity. Okay, however, in economics and financial time series, it is very rare to find the homoskedasticity conditions. Okay, so usually we have the period of while and also calm, okay, in economic and financial time series data. Okay, this, for example, okay, we have this period here is calm period, certain area from 1992 until 1996. This is a calm period. Okay, however, this is a financial crisis in ASEAN financial crisis in this period. There is a while, because the fluctuation in the while is bigger compared to the calm period. Okay. Okay, it is the explanation for the graph. I don't want to explain again this one. Okay, because there is no data that have the constant variance, so we take the conditional variance into our model. So the model become auto-regressive conditional heteroskedasticity. That means the heteroskedasticity is taken into our model as part of the model. Okay, so here, this is no longer linear regression model. This is non-linear regression model. This is non-linear regression model. Okay, arts is non-linear regression model.
Sebelumnya dari aku pribadi mengucapkan ribuan terima kasih banyak kawan-kawan.
Okay, the model is proposed by Eagle in 1982. Okay, he suggests that variance of residual in time t depend on the square error from the past error term. Okay, Eagle suggests that it is better simultaneously model the mean and variance. We have mean here. Mean is the regression and variance, okay, in our model together, because we do not have constant variance. Okay, this is a mean. The regression model is mean. Okay, in the classical linear regression assumptions, we have this model is constant variance, homoskedastic, constant variance. This is constant variance or homoskedastic model. Okay, here we assume that this zero mean and constant variance, zero mean and constant variance, because the variance here we thought t here or I in our model. This is the condition for the constant variance, zero mean and constant variance. Okay, Eagle idea start from the fact that he allows the variance of residual. This is a variance of residual. Depend on the past history. Past history is this one. Okay, this one the past, t minus 1. This one t. Okay, this means variance today is determined variance 1 day before. Variance tomorrow is determined by variance today. Because here only one time period, so we call this arts 1. If we have, for example, here, we have gamma 2 here, mu squared t minus 2. That means we have arts 2. And so on. Okay, this one, 2 lag period in this model for the arts 2. Okay, here again, this is the mean of the equation. This is the variance. You can check here, this is the variance. We impose the variance from here to here. So this model we put here because mu t here is the same here. So the variance is included in this mean model. So the model now become arch model. Okay. So this is the first is a mean here, mean equation. This is a variance equation. Okay. Arch 1 model indicate that when a big shock occurs in t-1 period, it is more likely that the value of mu t in absolute, because we make it become a square, also be bigger. If t-1 is small, the shock is small in t-1, so the effect also small in the next period. Okay, here, if this large here, so the effect also large. If here the effect is, the variance is small, the effect is also small. Okay, so here the coefficient of gamma 1 to be positive for positive variance. Okay, let me show you again here. This one is very important. This one very important to indicate whether our model, for example, this R1 or R2 depend on the significance of this coefficient. If this coefficient is significant at leg 1, that means we have R1. If we have this coefficient significant at R2, that's, we say this, it is a model of R2. So if you run the GARCH model, don't forget to check this one first. Okay, to determine whether your model is R1 or R2. Okay. Here R2, because we have two period leg here, R3 and RQ. Okay, depend on our model. Okay, you can read by yourself this one. If you have significant at leg number 3, that means you are having R3. If you have R1, that means you have one period leg is significant. Okay, this is how to test the GARCH effect. Key idea: this variance of mu t depend on size of square error term leg 1 period. This is one period. Model can be extended for higher. Okay, we can make -2, -3 until -p here. Okay, now how to test the GARCH. Okay, it is no need to read this one theoretically. I want to show you the model. Okay. Okay, first, how to check the. Okay, first, estimate OLS. Okay, get the residual. Okay, and then second one, test the homoskedasticity of the residual with the hypothesis. Hypothesis. Null hypothesis is homoskedasticity. Alternative hypothesis is heteroskedasticity. Okay, you can, yeah, okay, you can choose one of the homoskedasticity test to test whether there is heteroskedasticity or not in your model. Okay. If H null is rejected, that means you can apply the GARCH model. Okay, you get it? You understand?
Yeah.
Okay. First, we run OLS. We get the residual. We test whether there is a homoskedasticity or a heteroskedasticity. In this case, we hope we have heteroskedasticity. Okay. If there is homoskedasticity, you cannot use the GARCH model. Okay. Okay.
Yeah. So it means that in order to run ADO, you should have heteroscedasticity in your model.
How to?
You should have heteroscedasticity if you want to run it. There should be present of heteroscedasticity.
I can understand you. Can you write down, please? What do you mean?
Okay.
Are you typing? I mean?
Yeah, I'm typing.
Okay. Okay. Okay, I get it now. Oh, sorry. In order to run, it should be hetero. Yeah, you must have heteroskedasticity. Unless you have heteroskedasticity, so you can apply GARCH. If you don't have heteroskedasticity, sorry, you cannot use this model. Okay.
Yes, sir. Okay.
Okay, now we use the the FUs. Okay. Okay. Can you open your FUs? Okay. I use this data. Do you have the data? This one? ARW to 2020, 22. You have it? Okay.
Yes, sir.
Okay. First, we transform the data into log term. Okay. LGDP, we put this GDP, log GDP. Okay, if you have already this one, no need to, sorry, to transform it. Okay, now LM1 is log M1. We are estimating the money demand. Okay. Okay. First, no need to check the stationarity because it is a model of nonlinear. Okay. Now LM1. Can you follow me?
Yes.
Okay. LGDP rate. Sorry. LM1, LGDP, and rate. This is a demand model. Demand for narrow money. Open as equation. Okay. Still follow me?
Yeah.
Okay. Now we run this OLS, this least square model. Yeah. Okay, now we get this estimated results. We have a positive coefficient of GDP. This is theoretically significant and statistically also significant. This interest rate is also negative. This is significant theoretically because it is negative, and statistically also significant. Now we check the heteroskedasticity. Okay, we have click the view residual diagnostic and heteroskedasticity test. You get it?
Yes, sir.
Okay, and then you can choose one of them. You can choose half-a, laser, arts, wide, etc. Up to you. Bruce Pagan, okay. Okay, I choose white because white is more appropriate, I think. Okay, then run. Okay, we have this one. The statistic is 7 point something. The probability is 0.000. That means S null is rejected. Here we can conclude that our model has heteroskedasticity. Because the model has heteroskedasticity, then we can apply the GARCH model. Okay. And now we estimate GARCH. Okay, we change here from this square to GARCH. Okay. You get it?
Yes, sir.
Now change the GARCH become 0 here because we only estimating the GARCH. T GARCH is also 0. Okay. And now, okay. Okay, this one, this is a coefficient gamma. This gamma is significant. Okay. Okay, this one indicates that the model is GARCH1 is appropriate. However, we can extend our model become GARCH2, GARCH3, and etc. This coefficient of GDP also is positive theoretically, and estimated result also positive. That means significant, theoretically significant, and statistically also significant. The exchange rate, no, sorry, the interest rate is negative, theoretically is negative. The estimated result is also negative. That means theoretically significant. And the coefficient of the interest rate also statistically significant. Okay, GARCH model is appropriate. However, we can extend to make sure whether our model GARCH2 or GARCH1. Okay, now we extend to be GARCH2 and we run again. Here we get this one that the GARCH1 and GARCH2 is also significant. However, our coefficient of rate as interest rate is not significant. This means our model become worsen after increasing the GARCH model. Now, suppose we increase become GARCH3 here. Okay, how is the results? Okay, this one become is not significant. GARCH1 is not significant. GARCH2 also, GARCH3 is also significant, even though the coefficient of estimated is significant. Okay, suppose we increase become GARCH4 because this is nonlinear. Okay, that means we can stop. The appropriate model in money demand is GARCH1. Okay, because the GARCH is significant and the coefficient, both coefficients are also significant. Okay, you get it?
Yeah.
Any question? No question?
So I want to ask about, like, we tested at 1 is significant,
Hmm?
2 also is significant. So what is it possible, like 3 will not be significant, but if
Yeah.
we test for 4, then 4 will be significant. Is that possible?
Yeah, of course, because it is nonlinear. Okay, it's like wave. Okay, if you see this one, okay, I will write down here. This is like this one. Okay, sometime our model, this one here, 1 significant, for example, 2 is not significant, 3 is significant, 4 is not significant. You get it?
Yeah.
Okay, this non-linear model.
So in that case, which model will which one will you use? 1 or 2 or 3?
Okay, let me show you again this one. Okay, here this coefficient GDP is statistically and theoretically significant. Okay, first exchange rate, interest rate is also significant theoretically and statistically. This one, arts, is also significant. That means this is the best model in this case. Okay.
Yeah.
Okay. If you have next model, for example, all the arithmetic coefficients are significant theoretically and statistically, and R1 and R2 also significant, that means the best model is R2. Okay, you get it?
Yeah, thank you.
Okay. Any other question? No. Okay. Now we continue our GARCH model. Okay. One drawback of arts specification, according to Eagle, 1995, was it looked more like moving average specification than an autoregression. From this, a new idea was born to include lag conditional. So this additional variable is lag conditional. Okay, lag conditional variance as autoregressive system. Okay, this model is proposed by Tim Bolesev in 1986 with his paper titled Generalized Autoregressive Conditional Heteroskedasticity. So we know this one, GARCH model. Okay.
Excuse me, sir.
Yeah.
I want to ask a question concerning the GARCH model.
Mhm.
Is it only applicable when you're talking about the relationship between GDP and interest rate or exchange rate, or the model can be applied in other researches?
Okay.
Like quantitative research?
Okay. The first thing is if your model has heteroskedasticity, that means you can apply GARCH model. Okay, for any estimated model. Okay, you get it?
Yes, sir.
Okay. Don't worry, you can apply to other model. Okay, this example is only to explain for you. Okay. Okay, we have from the beginning we have arts model. Okay, this one. Now we add another one. This is one, GARCH. Okay. This is general form of GARCH model. Is 1 minus 1 until minus p here. Is 1 minus 1 until minus q. This means we have model GARCH of p q. Okay. How to determine P and Q, also like our GARCH model. Okay. As model is no longer of the usual linear form, we cannot use OLS. Okay, use another technique. The technique is known as maximum likelihood. So in your thesis, for example, you can explain that this study use maximum likelihood estimation method. Okay. Okay, this one how to estimate, I will explain for you. No need to this one. Okay. Okay, this one alternative GARCH and GARCH. Okay. Do we have GARCH mean? Okay. GARCH mean here. Consider investor, they are risk averse. Okay. Actually, investor, the types of investor, there are 3 types of investor. Okay. First is risk averse. Second is risk neutral. The third one is risk lover or risk takers. Okay, I'm asking you which type of investor you are? Risk averse, risk lovers, of risk neutral. Okay, here consider investor, they are risk averse and therefore require a premium as compensation for holding a risky asset. That premium is clearly a positive function of risk. High risk, high premium. Okay, low risk, low premium. If the risk is captured by volatility or by the conditional variant, the conditional variant may enter the conditional mean functions. Okay. Here we have here HT. We have here HT. We have HT. Okay. This is a mean. We put mean of the variant into this model. We call it GARCH mean. Okay. Now, in the estimated equation, mean is a square root of the model. Okay, square root of the ST. Okay. T-GARCH. Major restriction of GARCH and GARCH specification above is there are symmetric. Okay, GARCH and GARCH are symmetric model. But we also have another alternative of the model. We call it the T-GARCH. Okay. By this, we mean that matter is only the absolute value. In this one, is only absolute value of innovation, not the sign. Okay, because we transform the residual into square term. This means negative become positive. Therefore, GARCH and GARCH model as a big positive shock will also the same effect for the volatility with big shock, even though the shock is negative. Okay, because for example, we have -2 here. We square it, become 4. This one become positive. Okay, a big negative shock of the same magnitude. Okay, here all we have 2 and we square it, become also 4. But here the sign of negative and positive are unknown. How the effect of sign on the estimation result. However, for equities that has been observed that negative shock or bad news, suppose if you want to buy share or stock, you have to find out the bad news in the market. The bad news has a larger impact on volatility compared to good news. Okay. So this model is called a GARCH model. The GARCH model. So GARCH model at a multiplicative dummy variable. Dummy is calculated from the negative residual. Negative residual. Okay, we transform the negative residual become 1 and positive residual 0, and positive residual is 0. Okay, dummy variable into variant equation to check whether there is a statistically significant difference when shocks are negative. So we capture the shock negative from the residual. Okay, here we have this one. This one is a dummy. Okay, with the D text value 1 for the residual is negative and 0 otherwise. So good news and bad news have different impact. Good news has an impact of gamma. Okay, this gamma is a good news one, while bad news is gamma plus theta. Okay, this one good news. Okay, good news impact gamma 1. Bad news is gamma plus theta. Okay, this one case. Another one, we can capture the symmetry or asymmetry effect. Okay, if theta is greater than 0, we conclude there is an asymmetry. While theta is 0, that means is symmetry. Okay, you get it? So we have two parts here. Bad news and good news one. Another one is symmetry and asymmetry. If theta is greater than 0, that means asymmetry. If theta is 0, there is symmetry. Okay. Any question? No question? Okay. If there is no question, we use this one again. Okay. We run the same model. Now we change from GARCH model to GARCH. Here we put here 1. This is GARCH. Okay. Let's see the results. Okay. Here we have positive, statistically significant, statistically significant. However, this one negative is statistically significant, but statistically is not significant. Here we have arts is significant here because the coefficient is significant, but GARCH is not significant. Okay. We change again to be 1, 2. Maybe the appropriate method is 1, 2. 1 GARCH and 2 1 arts and 2 GARCH. Here this only arts is significant, GARCH is not significant. Okay, we change the model from here, suppose 3 to 1. Okay, this one okay now. This one significant, this one significant. Okay, this one significant, art significant, but GARCH is not significant. Okay, now we change again, become 3 arts and 2 GARCH. Okay, the rate is not significant. Arts one is significant. The other variables are not significant. Okay, that means it is not appropriate one. Okay, now suppose we change here. Here arts mean non. You can use this one, variant, log variant, standard deviation to choose mean. Yeah. So one variant, for example, here. Oh, it's singular. Okay, you one here. This is GARCH M 1. Also is impossible because it's a variant. We have standard error here. Also is a singular metric log variant. Oh, is this impossible to run this one? That means we cannot use arts mean here or GARCH mean. Okay, now suppose we change this one become T-GARCH. Okay, this is T-GARCH model because we have arts 1, GARCH 1, and T-GARCH. Okay, now we check the results here. The GDP is significant both theoretically and statistically, but the interest rate only theoretically significant. Here, arts is significant, GARCH is not significant, T-GARCH, this one T-GARCH, okay, this one T-GARCH. T-GARCH is not significant, GARCH also is not significant. Okay, now we change it to be 1-to-1, 1 arts, 2 GARCH, and 1 T-GARCH. Okay, here GDP significant theoretically and statistically, but the interest rate is not significant statistically. Here only arts is significant, but GARCH and T-GARCH is not significant. Okay, so we can conclude this model is appropriate model is arts 1. Now we test whether touch is significant or not. Okay, touch also is not significant. Okay, this means we can conclude this money demand model should be estimated by using arts 1 model. Okay, any question? No question? No.
Did you use the ARW 2002 data? Di ARW 2022 data Excel file.
Oh no, different file. You have different file.
No, it's the same. I'm just making sure.
Yeah, the same file.
Yeah. Okay.
You can use any other data. Okay. The important thing, you know how to estimate the GARCH model, how to estimate GARCH model, which GARCH model is appropriate, which GARCH model is appropriate. Okay. Okay.
I have a question in the chat box.
Okay, never mind. Go on.
No, I already typed it in the chat box.
Oh, sorry. Let me check. Okay. Can you use only the GARCH model in your whole research? Yeah, why not? There is no any restriction. You can use art if it is appropriate model. You can also use GARCH model if, okay, if the coefficient is statistically and theoretically significant. Okay.
Okay, sir. And there should also not be like any serial correlation.
No problem here. This is what non-linear model. Okay. In non-linear model, okay, in non-linear model, clear this one. In non-linear model, okay, all of the classical linear regression assumption are no longer valid. You get it? Can you understand me?
Yeah, yes, sir.
We have this one. This the classical linear regression assumption. The model must be linear in parameters. So we don't have linear parameters. This is classical linear regression assumption. Number one, no autocorrelation. Okay. No multicollinearity. Actually, this one perfect autocollinearity, yeah? And no okay. Okay, well, some of the assumptions of classical linear regression. So in the nonlinear model, these assumptions is not applicable. Okay.
Okay, sir.
Okay, now I want to show you this one from this one. Okay, we check here. Coefficient diagnostic, no. Gradient table. Okay. Oh, this is too much, yeah. Gradient. Summary. This one. Okay. This one, if you check this one, okay, this coefficient becomes smaller, smaller, and smaller, right? Can you get it? This one smaller, 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 smaller. Okay. This means the model is convergence model. Okay. So if the model is convergence, that means we can use this model as analysis model. Okay. Any other question? No question?